This is Honors Math 3, Unit 5, Section 2 Notes. Limits as the variable approaches a finite constant. More specifically, we're going to be talking about when x approaches a constant. So we can talk about the constant a, since that's what's given below. So continuity is when a function is continuous at x equals a, so x equals some constant, when the graph does not have any holes, jumps, or breaks at that place. So if we skip ahead a little bit, you can see that there is a graph below. So this function is continuous everywhere except for when x is equal to positive 1. There's a hole right there. But it's continuous everywhere else. So if I said this function is continuous when x equals a, I can use any x value except for positive 1. If f is continuous at x equals a, then the limit as x approaches a of f of x is equal to f of a. So right here, if I take a look at as x approaches 3, which would be my a value, as long as my function is continuous at x equals 3, then I can determine my function, this limit, by plugging in the 3 value for the x's. So let's check first to see if my function is continuous when x equals 3. This function is given to the right. So we're going to ask ourselves, is f continuous at x equals 3? And we'll go to positive 3, and the answer is yes. There's no holes, jumps, or breaks at positive 3, so yes. My function is continuous. Therefore, this is equal to f of 3. So let's go ahead and find f of 3, and then I'll know my limit. So f of 3 is 3 squared minus 1 over 3 minus 1. So all I did was plug in 3 for my x values. I'm going to go ahead and simplify that. 3 squared is 9. So 9 minus 1 over 3 minus 1 is 8 over 2, which equals 4. So my limit as x approaches 3 of x squared minus 1 over x minus 1 is 4. And that makes sense because when I go to positive 3 and find the value there, my y value, or my height of my function, is 4. So that creates the point 3, 4. But what if my function is not continuous? How would I find my value there? Well, first of all, let's look at an example where this function would not be continuous. So since my denominator is x minus 1, we know that there has to be a hole whenever my denominator is equal to 0. So you can also look at the graph on the right-hand side. At the x value of positive 1, there is a hole, and therefore is not continuous at that value. So if I find f of 1, I'm doing 1 squared minus 1 over 1 minus 1. 1 squared is 1. So I get 0 over 0. Well, that's not going to help me because that's undefined. There is a limit for this value, but 0 over 0 is not going to help me because that's not an answer that I can give. So to find the limit, we must reduce the fraction before plugging in our constant in order to eliminate the 0 over 0 condition before we do that. So we are going to rewrite this limit in order to simplify the fraction. So in order to simplify rational expressions, we have to factor, right? So I'm going to factor the numerator. And my denominator's already completely factored. But now I notice that I can reduce this, right? So x minus 1 over x minus 1 is 1. Therefore, this is equal to the limit as x approaches 1 of x plus 1 over 1, or just x plus 1. Now, I'm going to be able to plug in that x value. Before, I couldn't plug in my constant to find my value because it would give me 0 over 0. But this time when I plug it in, plugging it in for x, I get 1 plus 1, which equals 2. And that's true because if I'm saying my constant is 1, what is my height of my function at that hole? My height is 2. So this means there is a hole at the point 1, 2, and that is true. So if we flip to the back side, if we don't have the graph to look at, we're still going to reduce our functions in order to find the limits. Because if I plug in any of these values, I'm going to get 0 for the denominator. So instead, let's start to simplify. So simplifying my numerator here, I would have to factor it, and I can use the short method. So what multiplies to get x squared? That's x times x. What multiplies to get negative 8 but adds to get negative 2? That's negative 4 and positive 2. And then my denominator is x minus 4. So then those x minus 4s are going to reduce, and my limit is reduced, or my limit as x approaches 4 is now of x plus 2. So I'm going to plug in 4 to get 6. Ooh. So my limit is 6. All right, next example, we're going to factor this numerator. I have 4 terms, so let's see if we can factor it by grouping. So I'm just going to do all of my factoring work down below. That way I can simplify straight across. These are still 2 separate problems, but factoring my numerator first. So my numerator is x cubed plus 4x squared minus x minus 4. Let's try to factor that by grouping since there's 4 terms and see if it works. My greatest common factor of my first 2 terms is x squared, and that leaves me with x plus 4. My greatest common factor of my second 2 terms is negative 1, and that leaves me with x plus 4. If your factors are a greatest common factor within your terms, which they are because these 2 binomials are exactly the same, then you can factor by grouping. So that's the same, that's the same. So we're going to factor out an x plus 4, and we're left with x squared minus 1. Now, I know that the x squared minus 1 also factors. So let's go ahead and write our numerator, our factored numerator, into our problem up here. So we have x plus 4. But instead of writing x squared minus 1, what am I going to write? Here we're going to factor the difference of squares to x minus 1 times x plus 1. And over here I'm going to factor my denominator. So I have x squared plus 5x plus 4. You might be able to do that right up here. I know that 4x plus 1x is 5x, and 4 times 1 is 4. So I can factor by grouping, or I can also use the short method on this problem. The short method can be used on this problem because the a value is 1. So when using the short method, you're going to take your a term and say what multiplies to get x squared, that's x times x. What multiplies to 4 and adds to get 5, that's 4 and 1. And they're both positive, so each of these needs to be positive. And that's the same answer I would got if I were to factor by grouping. Now we're going to reduce. So anything over itself equals 1, so x plus 1 over x plus 1 equals 1. That reduces. X plus 4 over x plus 4 reduces to 1. The only thing I'm left with is x minus 1. Now I can find my limit. And to find my limit, I'm going to plug in x. So 4 minus 1 equals 3. This last one's kind of a challenge problem. Actually, no. You will have problems like this in your homework. So we have a fraction over a fraction. Now, I want to simplify my numerator, or simplify my numerator and denominator as much as I can before I actually divide and change my problem to a division problem. So first, let's change the numerator so that I have one term in my numerator. That means for the 1 over x plus 2 and the 1/2, in order to combine these together, I need a common denominator. So I'm going to multiply the first fraction by 2, that's this denominator, and the second fraction by x plus 2. So then that gives me 2 over 2 times x plus 2 minus x plus 2 over 2 times x plus 2. Since they have the same denominator now, I can combine them together. 2 minus x plus 2 over 2 times x plus 2. 2, well, I can distribute this negative. That gives me 2 minus x minus 2. And that's just 2 minus 2 is 0, so negative x over 2 times x plus 2. All right, this is only my numerator. I just started simplifying my numerator here. So if I'm rewriting my limit, this is my new numerator, but my denominator is still x. So if I want to change that, I'm going to change it to my numerator divided by my denominator. Numerator divided by denominator. Then I can change this to my numerator times the reciprocal of my denominator. So if my reciprocal of x is 1 over x, then negative x times 1 is negative x. 2 times x is 2x times x plus 2. And now what reduces is these x values. We finally have something that reduces. So my limit, as x approaches 0, of negative 1 over 2 times x plus 2 is my value that I'm going to actually plug my 0 into. Because up until the part where it reduces, my denominator would have still equaled 0. So now I can plug in a 0 without having my denominator equal to 0. So let's do that. This is equal to negative 1 over 2 times 0 plus 2. Negative 1, 2 times 2. Negative 1 over 4 is your limit.